Oh, no, 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 no. I need that.
Good evening, Jan. Or good afternoon. I could hear you just a moment ago. There we are.
I'm not sure whether I forgot to plug in
Ah,
my camera, but let's see whether I'm on the right speaker.
yeah, I am hearing the room audio.
Yeah. Where was that? They changed it again. The settings, devices.
No, devices are the devices that are connected to Discord. It's audio and video, I think, is what they call it.
Yeah. Before it was audio and video, but okay, I see it. Video and voice, and we take
This one, that should be better.
That's it.
Is it?
Yes.
Okay, there
Yes.
we are. Yeah, rushing to be in time. Um,
Well, I
I
appreciate
even,
that.
yeah, but I even didn't finish reading my chapter 7. Uh, I had a few remarks, but I didn't do the whole chapter, so I didn't send them to you yet.
Oh, okay. Well, I,
But but you're back on your new camera.
yes. I looked through the settings. I found the way to fix the autofocus. So now it's locked in, and then also compared the two cameras in the recording. And this is what my room actually looks like. This is the natural color. So yeah, the other one
Yeah,
is very washed out.
but yeah, I wanted to say, give that camera back to your wife. No, it's
Mhm.
not. It's now the room is more focused, but yourself a little bit more flu, not that very sharp focus.
Mhm. Yeah,
Oh,
I kind of like that.
but okay,
Yeah.
but it doesn't move anymore in focus, so it's okay.
Yeah, that was the big problem.
Yeah. So I even didn't read chapter 7 completely. Uh, no programming on historical modeling this week.
Mhm. Well, I do have some good book news. I finished chapter 13 and sent that off to the publisher, and so
Okay.
that is the last chapter, and now it's reviews. So yeah, I've got your reviews coming in. I've got Sander Mack's reviews coming in, and uh, and you remember Jeff Doolittle? Um, yeah, he
That's a while ago.
yeah yeah he agreed to write the forward. So he's actually even sending some feedback as well. So it's like, hey, this is great.
Okay. No, that's a long time ago that we saw Jeff.
Mm-hmm.
Is he still doing something in historical modeling? Because he
Yeah.
was.
So yeah, uh, he has successfully run historical modeling workshops. So he's kind of incorporated that technique into his repertoire, um, and he continues to run community groups that do book studies and that kind of thing. Um,
Okay.
so yeah, he's out there making a difference.
Okay, that's good news. Great. And
Yeah.
I still saw 5 minutes ago coming in a message from GitHub.
Yes,
Don't roll if a
indeed.
property is a helper. So
Hmm.
that means you are always busy.
Yes. Quite a few changes. So in fact, we can go to the GitHub pull requests and see what the various changes were since the last time. A lot of these are in response to the improving team that's using Janaga.net in a Maui application.
Okay.
Um,
Mhm.
so yeah, I want to make sure that I support them and I make this as as easy to use for folks. So if I go to, let's see. Okay, yeah.
Because actually on the patterns, now that we are talking about the team that is using the software, there was this, what was it? Yeah, there was this shared project, which you explained already a few videos, one of the later videos.
Yes.
But how are they doing it for the users? Are they using that shared project?
Yes. That is the intent. This feature is I've spec'd it out locally, but I haven't hardened it, and I haven't pushed that into the repository yet. But yeah, that is the intent. There is, well, actually, wait a minute. No, not this one. It is with a single use key. But the pattern that they are actually going for is more of the enterprise domain pattern, which is very similar, but it's just the intent of the project is a little bit different. So with shared projects, the idea is that this user here that has the managed key, they are creating a project in a system that is known to be multi-tenant. So that's the whole purpose of it. It's like a software as a service application. It's it's like Discord. A Discord server is a shared project. So one person just goes up to Discord, creates it, and as they create it, they will use a single use key, but then they immediately make themselves a member of it. So that's the purpose of the shared project pattern. The purpose of the enterprise domain pattern, even though it's got the same shape and it uses the same technique, the purpose is that this is now not a person creating a project in a multi-tenant application, but instead this is an administrator creating an environment in an enterprise. And so you expect just a small group of people to set up environments, and they're going to set up a small number of environments. So that's the pattern that they're going for at this point, because that fits better with the problem domain. But it's the same technique. But yes, in order to support this, where did it at some point I created some example code to show how to do this. Maybe I don't know if I even published that example code, but
not in the book. No.
Yeah, because that would be way too specific. It would be some C# code. But yeah, the idea is that you call a function on the Janaga client, and then you pass in a lambda. So it calls you back with the lambda, and the parameter to the lambda is this user. And so while you're in that function, you can call j.fact in order to create new facts as that user. So the idea is inside of that lambda, you get back this user, you create the environment administrator using your user object, and then you leave the lambda, and the client library will discard this this single use key. So the private key is used just to sign this this fact, and then used no more. Well, it's also used to sign the environment fact. Yeah, because that can that can only be created by this user, and then this can only be created by this user or another administrator.
Yeah.
Yep. So they are doing that.
And then somewhere in in the book. Yeah, that was about the content creators in the social network.
Mm-hmm.
There in the consequences, you write the fact graph is not well suited to finding new content creators to follow.
Mm.
To make content searchable, the application should project published content into a search index.
Yes.
Um,
Yeah, so the idea is that you're probably going to be looking for people who are your friends of friends. You're probably going to be looking for people who to discuss particular topics, people who have a particular reputation. So those kinds of queries are really what graph databases are designed to do. And so you can actually project it into something like Elasticsearch and get Elasticsearch to do that. It's okay at it, but something like Neo4j is, or Redis has a graph database that I really want to try out. Yeah, those are really great tools for these kinds of queries. The graph itself, it would be possible to do some of those. Like, let's suppose that, like here you've got published recipe books, and now you're looking for a published recipe book with a particular tag or maybe a particular ingredient, and you're saying I want to find those, and then I can find their authors and I can follow them. You would need to have some top level fact to start that search on.
yeah, but because for that graph,
mm-hmm.
for figure, what was it, 7.14? One of my remarks I wrote down was that there's the previous one.
Was it this one here?
One.
Okay, yeah, I can't see the
okay.
figure numbers in this view.
so this one, you don't have this follower and followed relationship. So the follow fact is not there.
Right. Yeah.
Which you do have in the picture before.
Mm-hmm.
But when you have that follow fact, so you can make a query that traces back to the other user at that moment. You can get his collection, you can get his content. And so if, for example, the ingredients, you would make them successor of the recipe, so of the content in this case, you could filter on it.
Yes. Yeah, so that would get you all of the recipes from users that you already follow. And presumably that would be a small enough set that you could have those two givens within your specification. So you're starting with this user, tracing back to the users you follow all the way down to their recipes, and then the second parameter is the ingredient, and you're tracing that back to the recipes. Assuming that, there's not something that calls out ingredient, but there is a little catch there. If the so this recipe fact here represents kind of the identity of the recipe, and so there's going to be some successors that will be the contents of it. So you'll have successors that represent ingredients and steps and photos and that sort of thing. But if you model ingredients as just a successor to recipe, then you wouldn't be able to create an ingredient fact without already knowing the recipe that you're talking about. But if instead you have a top-level ingredient fact, so I'm looking for everything that uses vodka. So I want to have a party and I've got some vodka and I want to cook with it and I want to make drinks with it. So then you would have to have a fact whose only field was the name vodka, and then you could use that inside of a specification. Now, if somebody had an ingredient that was, as you see commonly with people who sell and create and produce spirits, they will use their actual brand name as the ingredient rather than the generic name, and so you would have to have an exact match in order for that to work. So yeah, specifications are intended for walking the graph, but they are not intended for finding things that are close or finding things by value.
Yeah, well, that sounds similar.
Yeah.
Yeah.
So yeah, even in that case, even though you probably could make it work, I would still recommend that you project that into a search engine that is intended for those close matches and those value-based matches. And then it'll do a great job of that, and it'll give you some results, and now you can drill into that recipe. Now you've got the actual fact ID, and you can explore it from there.
Okay.
Yep, that is I've been finding something that a lot of people have questions about is that once I introduce this tool, it says, well, how do I get this tool to do this thing that I need to do? And sometimes that thing that I need to do is not really what the tool is good for. So that's one of the reasons that I start the book out in chapter 2 with these are all the things that it's not good for, and this is how you can integrate with those. So that way you get the best tool for the job. You know how to hook them together.
Yeah. No, it's a nice addition. These application patterns.
Yeah. Yeah. The idea of the application patterns that arose when I was working with one of my folks at Improving, and he was building a React application and wanted to use Janaga for that React application. So he it turned out his application was more akin to a social network, and the examples that I'd already built were more akin to enterprise. So so I'm showing them this enterprise code, and at the very top level, it does something different with users and and these top level facts than I'm asking him to do with his application, and then just had to talk in terms of just raw theory in order to even talk about the top level, and the interesting stuff was happening lower down in the graph. So it's like, I wish I had just a template I could give them and say, this is how your application should be structured. So yeah.
And then the pattern was born.
Yes, indeed. So, yep, Marcos, this is what your app should look like.
Yeah.
Very nice. Well, chapter 13, I am really excited about. This one is the proof of the inversion algorithm. So in the first edition, query inverses was earlier in the book. I think that was chapter 9, and it had a whole bunch of pipeline graphs. So in fact, I used pipelines in the second edition, but just for a little bit. So SQL databases. So when we talk about how to, was it SQL databases? I think it was. We talk about how to turn specifications into SQL databases. We first have to convert specifications into pipelines. So I lifted that part of the query inverses chapter and put it into the SQL chapter. So so now you can go from a specification to a bunch of steps, and then it's really easy to go from these steps to SQL, because that's what you're expressing. Each one of these, this very first one becomes your where clause. Each one of the filters becomes a where clause with a subselect. And in fact, sometimes I'll put that on the on clause. But then, you've got things that represent joins. So it became a language for turning specifications into queries, but it was not the right tool for computing inverses. So I completely stripped that out. And now if we go back to inversion, now we are talking about how to convert. Actually, let's go a little bit deeper into the chapter. Computing inverses. Yeah. So, if you have a specification that looks like this, what does that mean? That means that it's going to produce a set of tuples. It's going to produce a Cartesian product, ABC, where A is a member of, it's of fact type A, B is a B, and C is a C, so that tuple ABC is a member of the type ABC. But the specification also says these conditions that I haven't detailed out here, that's actually, those are the conditions, that's the projection, but these conditions here hold. So that's part of the definition of the set, and A is equal to some starting fact. So I know the identity of my starting fact, I pass that in as a given, and now I get back these tuples. So that's what that specification really means, if you boil it down. But the idea of inversion is that you can take away this part of that set, that condition, that constraint, and now you're left with all of the Cartesian products ABC that satisfy the conditions of the specification. And so, and now in order to invert it, if you have now learned of a new fact of type C, and you want to see which one of these are affected by that, then you plug that in as a new condition, and out pops the affected set. So, pretty cool stuff. And I want to pause for a moment here and welcome our new guest, M. How do you do? Good to see you. And that's fine if you want to stay on mute and just kind of hang out. But if you want to participate in the conversation, please just come off mute and let's talk. So transitioning, changing the view that folks see, so that we get a nice picture for everybody. So that was how I basically started the chapter on inversion, is that let's have another look at what a specification really means. We've already talked about how to convert them into SQL queries. Now, how do we reason about them? And being able to change which one is the given is the key that unlocks everything. And then from there, we can talk about how to rewrite them. Okay, so let's just look at this first part where I've got A, B, C. Now, if I take a look at those conditions that I was just talking about, B is going to have some path that joins it back to A, and C is going to have some path that joins it back to either A or B. or maybe two paths that join it back to both A and B. And I know that's the case because the specification has to be a complete graph. You have to be able to reach every one of these unknowns via some path. So in order to take something else, like for example, we'll start with B and move that up into the given spot, we'll first drop the given down into the body, and it won't have any conditions associated with it. So this is not a valid specification, but it's kind of an intermediate step. And then from there, now I want to rearrange the unknowns. So I'm going to move B up above A, but as I do, I have to move that path condition that joins B to A, because the path condition has to only relate to its current unknown and all prior labels. So I drop that into A, and I reverse the order, because by convention, I want the left-hand side to represent the current unknown, and the right-hand side to represent some previous label. So I move B up, drop the path condition into A, and then I can promote B to a given. Now notice that B can carry with it some additional conditions. So these would end up being existential conditions. And furthermore, they would also just represent existential conditions that only depend upon B. If those existential conditions depended upon any of the other unknowns, then it would have moved to those other unknowns as it was being promoted. So now we just have conditions that only depend upon B. So this gives you back a specification that has exactly the same meaning. It has exactly the same labels, the same conditions. It's just been rearranged so that one of them has been promoted to given, while everything that used to be in the given has been demoted into the body.
You have a practical example of where you would have an existential condition on B?
Yes, indeed. So let's... I think it might be in this one. Yeah, here's a practical example. So let's start with items in a menu. So yeah, we're starting to get into kind of complex examples here. So we start with a menu, like at a restaurant, and then we want to find all the menu items such that it's a menu item of that menu, and there does not exist a menu item deleted related to that menu item, such that there does not exist a menu item restored. So this is the the delete pattern and the restore pattern from the chapter that you already reviewed. Or wait a minute, the chapter that you're currently working on, chapter 7.
Yep.
Yeah. Excuse me. So that's the specification that we start with. Now we want to invert it. So yeah, this specification is going to produce products with M and I. Everything inside of I, like the label D, that's not going to show up in the product because it's part of a negative existential condition. It couldn't show up in the product because these results that you get back, MI, are precisely the ones that do not have a D, or at the very least do not have a D that has been restored, or that has not been restored. So now I want to invert it. So the very first inverse that I write, I've skipped over all the individual steps and just jumped right to the result. But What happened here is that I moved menu down into the body, and initially it was empty, and menu item was below that. And then I shifted menu item above menu, and so that means that I took the path condition that used to be inside of menu item, this one right here, and swapped the left hand and right hand sides, and dropped it into menu. And then the remaining conditions were just existential conditions that only depended upon I. They did not depend upon M. So that is an example there. And so if I receive a fact graph that says that there's a brand new menu item fact that you don't know about yet, then what I can do is I can run this specification to see, are there any menus that I'm currently showing on the user interface that need to be updated? Now, if that fact graph that I just received includes menu item deleted, but no menu item restored, then I can skip that step. So I run the existential condition for that menu item that I'm plugging in here, and if the condition is not satisfied, so such a thing does exist, then this specification just returns no results. And that means
It has no influence on the menu because
Precisely.
it has been deleted and not restored.
Yep.
Okay.
Yep. Yep. So the
See, with
argument.
with the nice menu, everything is more clear.
Yes. Yeah, and the argument that I present here is that that was a mechanical operation. I wrote code that just does that. The developer didn't have to think through that use case. So, and then I continue here, and so okay, now when I learn about menu item deleted, what is the effect? Well, the effect is that I can find the menu item that went with and the menu for that menu item, and I know, okay, that's what needs to be updated, but only if that menu item deleted has not been restored. And the update is going to be to remove that menu item. So I get this product here, DIM, so D is the given, and then I and M are the two unknowns. So I produce those products, and now I look at M, that's my affected set, and say, do I have a view that started from that menu? If so, okay, I need to update that view. What do I need to do? I need to find this subset, IM. I need to find that particular menu item, and I need to remove it. So not only does this tell me exactly what views need to be updated, it tells me exactly how to update them. So this the presence of DIM in this inverse tells me that IM no longer satisfies the conditions. And so that inference continues, and I and I find all of the inverses, and the inverses tell me how to update the caches, and it's mechanical. The runtime did that. The user didn't have to do that, or the developer didn't have to do that. So yeah, that means that the developer gets the benefit of a mathematically proven algorithm and doesn't have to reason through all of the use cases. The product owner or the data analyst doesn't have to document all those use cases, and the tester doesn't need to test all those use cases. They probably will anyway. I would, but they are extremely unlikely. It's extremely unlikely that they're going to find a defect. So, assuming that I get the code in Janaga.net right, and assuming that we've specified the original specification correctly. But yeah, that's what you're really testing for now, is you're testing that your specification matches your intent, not that you've properly implemented your specification. So I'm pretty excited about this chapter. This one's pretty good.
Yeah, we still have a few
You
chapters
hear
to
me?
go before we get there.
Yes, yes, we can hear you.
Ah, okay. Hey, sorry.
Oh,
To
not a problem.
just drop in, folk. Um, just I had some problems before. I'm no, not greatly connected. Hi.
Hi, how are you doing?
I'm
Hi.
Lucas. It's nice to meet you, and just dropping in to say thank you for creating all this content of also of the book, and all, this discussions you just had are very enlightening. So I think these are very important for actual developers when they get around to actually use them.
Mm-hmm.
So I'm pretty excited to get at some point actually use it for something. I'm still working on a version of my own.
Mm-hmm.
It's not as sophisticated because it is not needed, but I think it's very great that there's some proven way to actually convert this mechanical, to create these mechanical inverses, which create all these nice properties. So I think that's very, very helpful.
Yeah,
And,
thank you.
Even if there's no way to actually use your code or the directly using your concepts, knowing that there is a way,
Mm-hmm.
if you model it correctly, that's already a good thing.
Yeah.
I have a saying that if something does not work in theory, you cannot forget to try it in practice, right?
Right.
So if it's proven to not work, and people try that all the time.
Yeah.
That's weird, but that happens like all the time. So it's nice to see that it is actually possible to do that. So
Yeah.
I appreciate this whole work, and also I'm here to look at the new book and maybe have some new insights from it.
Excellent. Yeah, thank you.
I actually missed the topic of today, so that's why I'm just dropping in saying hello.
Yeah. We often don't have a preset topic. Sometimes it's like, hey, I just did a thing and I wanna show it. But yeah. Today no preset topic, but some exciting news. Yeah, chapter 13 is out.
Yep.
And so yeah, the what's really funny is the proof that I had in the first edition using pipelines. When I
the blocks and types
Yes.
and filters thingy.
Yes. Yes. So when I got to the end of that chapter, there was like some it kind of acquiesced. It sort of said, this works in these cases, but it doesn't work in those cases. So in those cases, just rerun the query. And so I actually found this other way of thinking through inversion when working on Janaga.net, because Janaga.net is based on LINQ, and LINQ kind of forced me down this idea of having the unknowns in the conditions. That's kind of how you set up a LINQ query. And then kind of took that back and reasoned through it, and it's like, oh, wait a minute, that makes the problem so much easier. And so, when I got to the end of this proof, it's like, it works. It's complete. I have a proof of completeness. This is awesome. So this can actually handle those cases that the other one couldn't. And I think it's easier to understand, too, in the, and just as happened with the first edition, while writing this proof, I found some bugs in my Janaga code. So it's like, oh, wait a minute. There's this case that I need to do this extra thing for in this proof, but my code doesn't do that. So I do have some bugs to go back and fix in Janaga because of this. But
there always are some bugs, right? That's how it is, right?
I'm of the opinion, this might be a little bit of a hot take, but I am of the opinion that it is possible to write bug-free code. It takes a lot of work. I think that if you were to look at some like take a look at Postgres, one of the best written relational databases, and hardened because lots of people are using it. I would argue that the chance of finding a bug in the Postgres query generator. It creates query plans. The chances of finding a bug in that code now are extremely low, even though that's got to be some really complex code. So I think that that if the code is general purpose and it's used for it's used by a lot of domains, and they all go through that code path, that it's possible to to rarefy, to actually find them all and get to a point where you don't have any defects.
I do agree, assuming that there are not too many paths. So if you look at the Linux kernel source code, like they're still finding bugs left and right, even if it is tested millions and billions of times. So it's just tiny paths, and the permutations are just insane. So there's no way we can actually cover everything. So I think we limit ourselves like very much, be very restrictive. Yes, I think we can actually get rid of all of them. But if we run into this permutation, into explosion of possibilities, then we just run out of test cases in the real world, right? Somehow.
Yeah, that is a good point. And in fact, I haven't done my research to see how often are people finding bugs in Postgres. I mean, it's an active open source project. Surely they're some of the work they're doing is bug fixing.
Yeah, but I appreciate the idea that it is actually possible. Many things things I dislike about culture and software engineering is that things are just given. It cannot be done that there are no bugs, so we just live with them.
Yeah.
Even if many of them can actually be removed, or we have some complexity, just live with that. But maybe we can do something about that. Have reduced complexity and avoid both in features which are not actually needed. So every line of code I actually do not write is a win, whatever you do.
Yeah, that's true. Yeah, if you were to look at a 12-line Python program, that has a list, and then it applies a filter to it, and shows the results. Okay, just show me the odd numbers. Okay, you can look at that code, you can reason through it, and I'm pretty sure that you can get to the point where you have confidence there are no bugs in that code. But that has very low complexity. So yeah, if there are bugs in the generated program, maybe there are bugs in the Python runtime, and those I think are rarefied. Yeah.
But if you look at something like Haskell code, and you could reasonably reason through it, right, and prove that it is actually up to specification, and then we are at the same point you are discussing, as you were saying before.
Yeah. That's yeah, quite all right. Yeah, I think that is the one claim that I actually can stand behind. The other is just my hope that yes, we can rarefy our bugs, but yeah, I think the one claim that I can stand behind is if you try to solve these problems over and over again with each domain, your chances of writing bugs are much higher than if you were to use something that has been proved mathematically and proved in the real world. So with lots of people banging on it. So
anyway, I think that the Jinaga runtime will definitely help in reducing bugs. Not everybody has to write the code again for himself.
Yeah, that is my hope. And in fact, I started seeing a little bit of that with the improving team that is working on this application. So we have these regular meetings where I'm going over the model and making my recommendations. and they're able to ask questions. And it's in those meetings that they say, and I think I found a bug. And it's like, yep, that was a bug. Yeah, let's enter it. Let's fix it. But I think that the bugs definitely have not been verified out of Janaga.net yet. It's just getting started on that process. But one of the things that I've found in these discussions is that if I weren't to warn them against a particular pattern, and they're using unit testing to explore these patterns to begin with, if I didn't catch something and I didn't warn them against it, eventually the unit test would have showed them what the problem was. So yeah, I'm thinking about like one example is they wanted to use GUIDs to identify a fact, but Janaga.net did not yet support the GUID type. Now it does. That's what that that last commit that you saw was all about. But yeah, so it's like, okay, it's complaining when I try to use GUIDs, so I'm going to switch to integer, and I've got an ID in there. And so my question is, how do you generate that ID? How do you know that you've got a unique ID on each device? And they're using Janaga because they want these mobile devices to be offline capable. So it's like, yeah, I would call some central service, and it would use a sequence to give me back an ID. So, but you can't reach that central service. Oh yeah, okay. So I can't use ID as the only field in order to identify, in this case, an order. So order ID is out. What do we do? Well, GUID is the correct thing to do. Let me make that work. But in the meantime, you can convert a GUID to a string, and that would work. But yeah, their tests would lead them to a place where it's like, okay, I'm creating this fact. Either the test would just hard code an ID, or they would discover, okay, I don't have a place to get this ID from. So I think that, at least what I hope happens, is that the constraints that are built into the library, the idea is those are constraints that are part of distributed systems in the first place, but we usually don't encounter them until we deploy to at least the test environment, sometimes to production, and we get lots of different microservices working together, and then a situation arises and we see a defect, and then we have to dig through and find out what caused that defect. So my design here is to put a constraint in the API so that you can't express that situation that would lead to that defect. And I think that this might be evidence that that's working. So hopefully that will be just true. And then as soon as you get to a point where you can write unit tests that make a lot of sense and work, then your model is right. I can't prove that, but that's my hope.
Just one question. Are you into mobile applications, or are you doing research? What is your specialty? And what brought you in contact with historical modeling?
Actually, the book. So I have no idea where it popped up somewhere, but I have been working on many things which relate to somehow events happening. So I keep notes. So I'm a software engineer, and I keep notes of work, and there are many ideas where I recorded ideas. How we do that, how we do adaptation. I was really looking to hybrid media and things like that, which are very explicit, and also functional programming. So, and the idea that there is bug-free code, there is a way to express different things. That limitation is a good thing. The correct, if you have the correct rules applied very strongly, will actually keep you free, keep you from doing stupid things. So that's what compilers are for. That's what also these kind of rules are for. So what I'm trying is to currently use a system which is inspired by the historical modeling. It is also keeping a historical model, to solve a distributed computing problem. So, this is also about synchronization, and it's about IoT system, which is in a limited environment. So it's very limited about the computing power. It's limited in how much bandwidth it is available, but it is also needed to be able to cope with partitions and network fails, and have some the ability to have multi-masters. So if I have multiple, instead of just having a hierarchy, having two master systems which are able to command, or so it can be mission critical. That's why what brought me here, and I'm actually using it. It's not using the ideas, the concepts. I write the whole thing myself because it's first not applicable. It's using Java, and it's trying to do is more limited. So the whole power of this specification will be too much.
Yeah.
It's more of a platform for applications, and what I want to do is more narrow.
Yeah.
So, yeah,
I like
that's
that.
what
Yeah.
brought me here.
Yeah. Thank you. Yes, the our Java support is not even on the backlog yet for Janaga. It will have to get there eventually, but yeah, that makes a lot of sense. And in fact, when I first started thinking about historical modeling, I used it first as an analysis technique, and then in order to build systems. Hey there.
She can't hear. But I think I'm going to turn off the screen. Okay.
Okay. But yep. Good. That's really good to hear. For years that was exactly what I did. Just use these rules in order to build systems, and then run the requirements through the rules in order to figure out what problems we might run into.
Yeah, it's already helpful. It's helping very much on my side. So I can prove lots of things, and I have more like a model approach. So we can tack on different models onto a historical storage, and you can replay the model, and so you can restart, you can recover, and you are very flexible.
Excellent. Yeah. So it sounds like kind of a historical modeling analysis, and then some of the implementation is bringing in some event sourcing ideas.
Along these lines, yes.
Yeah. I love it. Well, excellent.
Okay, I think I'm gonna check out. Thanks for all the content. I'm gonna keep on watching. I'm gonna need to.
Very good. Yeah, very good to meet you.
Nice to meet you.
You as well. Have a great day and good luck.
Bye-bye.
Excellent.
Yeah, these small children are the best testers.
Yes, they are.
I remember when my kids were small, you were testing the whole time, a user interface, is everything working fine? And then they come, they say, Papa, and they start knocking on the keyboard by accident, and immediately the software hangs. You say, well, I thought everything was working fine, and immediately the program crashes.
Yeah.
No, I had it multiple times. I think our testing is too much constrained. We limit ourselves to a number of actions, while somebody who's really without these constraints, a small kid, does things that we are not testing for.
Yeah. Yeah, there was a scene in 2001: A Space Odyssey, where the researcher that was looking into the obelisk, he's on the space station, and he has a video phone call with his daughter back on Earth, and so she's using the phone, hi Papa, and then she's also playing with all the buttons, all the controls on the chair, and of course they didn't direct the child to do that, and of course it's just a prop, so nothing bad happened. But they left that in the movie, so now the interpretation is this user interface is so smart that when it sees random inputs, it ignores it. So yeah, best tester.
Uh, and that's only user interface. That's even not the underlying software.
Yeah.
Good.
Yeah, very good. And so some of the other things that my team found as they were using the system, not as as children, but as people who are just thinking outside of they're experts in development, and they just used tested things that I hadn't thought to test. So yeah, it was the GUID thing. I was like, oh yeah, need to support GUIDs, since I talk about using them as identifiers in the book. I mean, it's got to be in the code. And then another thing was when they had a string that had an apostrophe in it, then it raised a really strange looking error. So yeah, they said, I suspect that there might be some SQL injection going on here. And I say, yep, absolutely there was. So yeah, one of the changes from this week was to go through that SQLite code and use parameters for everything. So it was really just the data, just taking the JSON object and passing that one in. The rest of them were, well, I guess fact type would have also been a problem if you put an apostrophe in a fact type. But
it's true in the SQLite code we didn't use parameters.
Yeah. But the good part is GitHub Copilot knows about SQLite. So I say, hey, select this code. Can you modify this code to use parameters? Sure. Boom, here's the new code. All right. Paste that in, run the tests. It works. Yep.
Yeah.
So Copilot just did them all. Now I couldn't tell Copilot, just go through the code, find them all. Instead, I went through one by one, selected it. Okay, great, now do this one. Oh, you're doing great, now do this one. I gave it some encouragement, probably not necessary to do that. But, I want it to know it's doing well.
For the moment, encouragement is fine. Later, Copilot will on strike and will ask for a raise in salary.
Yeah, it's like, how many more of these things do I have to do? Yeah, so I even told it, all right, we've got 2 more to go.
Wait until the artificial intelligence becomes more human. And then they go on strike. For the moment, in France and in Belgium, all the roads are blocked by angry, how do they call that, farmers. So... Yeah.
There was there was a strike in the U.S. I think it was 2020, maybe 2021. With the shipping. So truckers, just use their I guess you would say lorries, use their trucks to stop the road.
Well, in France we are used to it, to strikes, but it looks like it's getting over all Europe. First France, now Belgium, and we will see. And the day that artificial intelligence gets more human, then we will see.
Yep. But I constantly have that. Just recently had that conversation with Jenny, and I brought up Copilot and said, "This is the current state." Just 6 months ago, it wasn't able to do this, but now it's able to do this. This is the current state. Let me show you what it does well. Let me show you all the mistakes that it makes. What it does poorly. And so, I think those of us who are working with ChatGPT all the time, working with Copilot all the time, having those conversations with our family and making sure that they understand what it does, what it doesn't do, what to look out for. I think that's just going to be part of life as we watch it slowly march toward AGI. I think we're a long way away from AGI, but still have to watch the march.
It goes every day. It goes faster and better. So there is always a solution, a good solution.
Yeah. Yeah, I think so. Ultimately, I think so.
Good.
Very good. Oh, I wasn't paying attention to the notes, but yeah, Homero it was is watching on YouTube. So hi, Homero, if you're still there. Yeah, I'll be talking at the mobile the DFW mobile.net user group that Homero hosts. So that is coming up at the end of February. But yes, in answer to the question, are the updates automatic? Meaning, would the user wouldn't have to perform any sort of refresh? Yes, that is the case. These updates that we were just talking about with the inverses, they will happen immediately when this machine learns about a new fact. So it could learn about a new fact because the user themselves just did it. Or it could learn about a new fact because it just downloaded it from a replicator. Or you could use the subscribe method, not yet supported in Janaga.net, but will be soon, to get push notifications of those new facts. So yeah, that's going to be exciting when it's like, just write this and it works. And it's like, but what about updates? It just works. It's built in. Yeah.
So this user group, that's an online event, or
This will be an in-person event.
okay.
But yeah, Romero, maybe you can tell us if we will have a recording or maybe even live stream. We'll yeah, certainly I'll make the content of the discussion available in some form, even if it's just re-recording what it is we talked about. But yeah,
that would be nice.
Yeah.
Anyway, the 22nd of February, from 22nd of February until the 8th of March, I will not be there.
Okay.
Go and join my wife visiting my family-in-law. So
Very nice.
Another 7 or 6 hours of time difference. No, traveling to Malaysia.
Excellent. Well, enjoy that trip.
Yeah, but we are not there yet. For the moment, I can still try to catch up with some work. So for the next week, I'm gonna finish that chapter, and I haven't looked at the next chapter whether that's a very big one. So to catch up a little bit, and then hopefully I find some time to start with the DWS model. Because I'm really getting behind on everything.
Yeah, well, that'll be really exciting. Yeah, I think that process is it's going to go pretty fast, and it's going to be a lot of fun. That's what I'm seeing with the with this improving team, and in this case, you've got all of this prior experience with the patterns and with the implementation, so I think it'll go even faster, even smoother.
Well, I was thinking in the beginning I wanted to start the complete new development, but I was still having another potential customer on the line, which was also using Apple phones.
Yes.
So there I started thinking, if I just copy what I have, but in historical modeling, then I can deploy it on Apple as well, on iPhones, and without changing anything. But of course, yeah. Then I'm implementing the current system, not new, but it might be a good start, and it might go faster.
Yeah.
And it.
Yeah, and these things are they always have to be incremental because you have existing customers with existing data, and they're going to want to upgrade to the new version. So yeah, you have to have something that speaks both languages.
So, I will think about that this week.
Very good.
Good. Michael, see you next week.
Yes, indeed. Next
Okay.
week.
Bye-bye.
Bye.